So we're gonna start like preparing for next season because many of you guys were first year team members. So now that it's our off season, except for me, but don't worry about that. We're gonna start learning in preparation for next year. So this is gonna spend 2 weeks on this, and this is FTC Drivetrains. So what exactly is a drivetrain? Well, a drivetrain is basically what moves your robot around certain terrain. So this year, it just happened to be all flat surfaces, but the past 2 years, there were like multiple obstacles on the ground, such as like a low bump or even an entire like rail on the ground where you have to roll over. There are many factors to consider when making a drivetrain. One is the speed and control. So that's mainly just like what kind of motors you want. In our case, we only have one type of motor, and that's a 312 RPM motor. But there are other motors such as 60 RPM, which favors a lot of torque over speed, and there's some as high as 6,000 RPM, which favors speed over torque. And that's good for speed because you want to drive like fast around the field, get to as many places as quick as possible. We also want control. How fast can it operate? Is it easy to control? Pretty much, you don't want your robot just bumping everywhere because like in today's game or in this year's game, you bump the backdrop, you de-square everything. That's a lot of points. So you maybe want to like slow it down a little. And maneuverability. How well can it weave between certain obstacles? So how well can it like go around certain obstacles? Can it only go in a straight line? Can it also straight or rotate on like in its initial position? Traction. So wheels like this is an Omni wheel. It's good because you can move forward and you can go sideways. But the problem is the rollers make the traction really bad because it's prone to slipping, and if a robot bumps against you, then you don't really have good defense on that. Motor servo usage. So for FTC, the requirement is you can only have up to 8 motors and 10 servos. For other competitions like FRC is a bit different, but in this case we're just focusing on FTC because because our team has an FTC team. So some drivetrains only use 2 motors, which means you have 6 more to use for like any scoring mechanisms. Most drivetrains have up to 4 motors, which is the most ideal, but at the same time you could use other motors for certain mechanisms. And lastly is space. Is there room for other electronics and mechanisms? Because the robot, at least for our competition, has to fit within an 18 by 18 by 18 inch format. And in some cases, like this year's, we wanted a robot that can go under the truss, which is 14 and 12 inches respectively. So our robot can go under the door because it's like around 11 inches, which can go under the lowest door. Yeah. So this is one example of a drivetrain. It's called the 2-wheel drivetrain. I actually have an example from one of our VEX robots. So 2-wheel drivetrains are easy to program. They consist of 2 normal traction wheels in the back and 2 dead axle Omni wheels. This allows for front wheel rotation movement. So in this example, you can see that there are 2 Omni wheels over here. These are dead axle. There's no motors attached to it. And there's 2 traction wheels over here. These have motors over here, and you can kind of hear when you rotate, like the motor. And this allows for front wheel rotation movement. So these Omni wheels, because they have side rollers, they can kind of roll forward like this and sideways without any like rubbing against the surface. And with these 2 traction wheels, it can allow for like rotation like this. So a pro of this drivetrain is that it saves motors and space for other mechanisms because it only uses 2 instead of the typical 4. And it has pretty decent acceleration, just go forward. The downside is that maneuverability can be awkward, similar to a car. You know how like in a car, only the 2 front wheels turn, right? Similar to this can only rotate and go forward or backward. It cannot strafe sideways. Like you can kind of hear like what sound that makes. It can't go sideways. It has terrible traction because if you just bump it like this, I barely use any force and it already moved forward, which is bad if a robot's playing defense against you. And like I said, it cannot strafe, which limits the robot's capability. So a 6-wheel drivetrain is just like a 2-wheel, except instead of having 2 dead axle omni wheels, you have another set of 2 on the back. So you have the 2 traction wheels in the center. And they do tend to be more sturdy. And yeah, the pros is that it also uses 2 motors, which is pretty good. You have 6 motors for other mechanisms. Good acceleration, just like the 2-wheel drive. And unlike the 2-wheel drive, it has great traction because it has the 2 traction wheels in the middle instead of in the back. So if you bump it over here, it won't really bump as much, or on the side, because the wheels kind of like center the amount of traction that this robot can take. That side is just like the 2-wheel drive. You can't really strafe sideways. A tank tread drivetrain it used to be popular in FTC, but not really as much anymore. Basically, you would see in like military automobiles, tank treads use tread chains that are controlled by 2 or 4 servos, typically just 2 servos, and it's common in military machines for its good defense. So it has pretty good traction and speed, and it can adapt to different terrain. So if there's like a huge obstacle, like let's say my arm is over here, it can easily just roll over it because the tread or the tank treads can adapt to its terrain. And of course, it uses up to 2 motors. Only problem is no strafing. It can be pretty slow at turning, and it's pretty bad at maneuvering. So now we're going to move on to holonomic drivetrains. So as you can see right here, this is our competition robot, except missing its side panels so that you can better see the wheels. And essentially, mechanism wheel drivetrains are the most popular at FTC. Almost every team uses it, and they have really excellent all-around capabilities. It does require like a detailed understanding of how these wheels work. For example, you can see over here, you do have to be mindful of how you mount these wheels, because these are at 45-degree angle rollers, and you can't just slap a random wheel onto whatever and say, oh, it works. These have to be mounted at a certain angle. Typically, a way I like to see it is if the angles make this X format to the center. So let's see, you see over these rollers over here and these rollers over here, they point this way diagonal, and it's kind of hard to see over here, but these wheels are pointing diagonal, and they kind of make like an X. Then you know you have the right configuration for the mechanism wheel drivetrain. The pros is that these are capable of holonomic movement, which basically is it can move forward, back, it can rotate, and unlike the 2 and 6-wheel drives and the tank wheel drive and the tank treads, it can move sideways. So it's pretty good for maneuvering. It also has good acceleration as well. The only problem is it does use 4 motors, which is okay. I mean, people don't really have a problem with that, but if you do want more motors for different mechanisms, then you're gonna have to think out the box for that. The traction is decent, but it's still not perfect. It still has some slippage. It's still better than a 2-wheel drive, but it still has a little bit of slippage. And the sideways strafing is slightly slower than forwards backwards movement, because when you move forwards and backwards, it just rotates the motor. But when you move sideways, the motors spin in a way where the forces between the angled rollers counteract each other. So if you run the motors at the same speed, compared to front and back movement, sideways movement will be a tiny bit slower. Just a tiny bit though, not too much. An X-Drive drivetrain, this is something that Whitney did last year. X-Drive utilizes 4 omni wheels in an X format, so you can see right here and right here, like the mechanism wheel drivetrain. X-Drives are capable of moving anywhere while maintaining its relative position. It also does require having extensive knowledge of how it works. Pros, just like the mechanism wheel drivetrain, is that it's capable of holonomic movement, and it has good maneuverability. I would say it's even better than the mechanism wheel drivetrain because its acceleration is almost equal in all directions. Only cons is it does use omni wheels, and unlike mechanism wheels, omni wheels have less traction than omni wheels, so it's much more prone to slippage if it bumps into an obstacle, if it bumps into a moving robot or another moving robot or just an obstacle in general. So it uses 4 motors and the traction is just terrible. And then now we're going to move on to, these are considered like incredibly advanced drivetrains. This one is a coaxial swerve drivetrain. So all swerve drivetrains are more difficult to make due to the amount of electronics needed, but they are more powerful in many fields and are mainly found in VEX Robotics competition FRC. FRC is basically this, but in like a 3 or 4 feet box, and they do much more active things. They're also a lot more expensive, which is why we're an FTC team. Coaxial swerve drivetrains utilize 4 traction wheels that turn at the same direction. So let's just take your swivel chairs, for example. You look at the wheels, you can see that when you move them, the wheels will automatically move towards the direction it's moving. That is a swerve module, except in this case, it uses motors and servos to turn the wheels so that it moves on its own without any movement. The pros is that it has great acceleration in all directions because the wheels move in unison. And it also has great traction because you can apply active braking to the wheels. And because it utilizes all 4 traction wheels instead of wheels with rollers like mechanism or omni wheels, you can use the motors to brake, and in the result, the traction wheels will do its work and it has pretty good traction. Only problem is it does use a lot of electronics. You need a motor to run the wheel, and then you need a servo for each like swerve module to turn the wheel. And there's less space for other mechanisms because lots of electronics. And because of those electronics, your battery voltage it's a lot less consistent, and it can drop in some cases, which is bad for a robot because you want to maintain a good battery voltage throughout the match. And then a differential swerve drivetrain is a lot like a coaxial drivetrain, except it only uses 2 swerve wheels instead of 4, which means only 2 motors. So it's actually really crazy that you can have a swerve drivetrain with only 2 motors, which can save a lot of space. That shows 4 motors, but from the research I found, you can do 2 motors too. So a differential swerve utilizes traction wheels that can turn in all directions. However, only 2 wheels are used, and the entire drivetrain is powered by only 2 motors, similar to a 2-wheel drive and a 6-wheel drive. The rest of the drivetrain is supported by 4 dead axle omni wheels. It's important to have those omni wheels in there so that all 4 corners of the robot have like 4 corners of support, while the 2 wheels are over here. Because you can't just have 2 wheels in the middle, otherwise it can tilt. So you need something to support it. That's why there's 4 omni wheels in each corner. Pros: great acceleration in all directions, great traction, and not a lot of motor usage. Only downside is it's really hard to make. And if you do it right, you can get a lot of points, especially for like an innovative robot and design as well. But it's a trade-off, it's pretty hard. I don't even know how to make it. So how do you choose a drivetrain? Because every drivetrain has its pros and cons. So despite this slideshow covering the most common drivetrains, there are a lot more out there that I haven't covered. They just aren't really used that much. Even though each has their weaknesses, it is important to rely on its strengths too. The criteria may vary between seasons. So each season has a different game theme, and you might want to utilize that game theme to decide what kind of drivetrain you want. So tank drives, which is the 2 and the 6 wheel, and of course the tank tread. Tank drives are good if you require more motors for other mechanisms, such as a flywheel. So this year, when you launch a paper airplane, This year, when we launched paper airplanes, some teams decided to use or to dedicate a motor just to like launch the airplane using 2 wheels that rotate in the like clockwise and counterclockwise pattern, moving the robot forward. Some also offer better traction and speed for as little as 2 motors, just like the 6-wheel drive. Polynomic drives, just like the X drive and the mechanism wheel, have medium tractions and are good for all-around movement. They offer a balance between maneuverability and speed, which is why it's favored among many teams. And lastly, swerve drives check both the traction and speed marks, and if done correctly, can be considered innovative and unique for now, but it's also really hard to make.